Welcome back, class. In this video, we are going to go through Chapter 2, Section 2, Histograms. You might have remembered histograms from your algebra days if you touched on probability and statistics. And the basic idea of a histogram is we are taking the frequency distribution tables we did back in Section 2.1, and now we're going to be making a graph out of them. So we're taking the chart and we're making the graph, which is a easier way for us to interpret the values than just a table of numbers. And a histogram is basically a bar graph, the same bar graphs you've been doing since second grade. So it consists of bars of equal width. So these each have the same width. These are the class widths right here. The horizontal scale represents classes of quantitative data values, and the vertical scales represent the frequencies, how many times it appears. It could also be a relative frequency along the y-axis, and the x-axis is always going to be your classes. So the important uses is that it visually displays the shape of the distribution of their data. It shows the location of the center of the data, shows the spread of data, and it identifies any outliers. Okay, so this is the example that we did in problem chapter 2, section 1 with the McDonald's lunch service times. So we created this table in section 2.1. But instead of just looking at the frequency distribution table, now we're going to plot this on a histogram. So each of the 5 classes represents one of these bars, equal length, and then the y-axis is going to be the frequency. So 11, 24, 10, 3, 2. And now it's an easier way to visualize where each of these have more data values, and we can really see the distribution. It's kind of a normal curve. It's actually a skewed curve when we're going to get to that later in this section. You can also do a relative frequency distribution. So it'll actually have the same exact shape and horizontal scale as a regular histogram, but the vertical scales of a relative frequency histogram are going to be marked with relative frequency instead of actual frequencies. Nothing crazy right there. So over here, the y-axis was the how many times each frequency appeared. Now it's the percentage. So 22%, which is 11 divided by 50. Again, that 50 came from 50 total data points. If you add 11, 24, 10, 3, and 2, you get 50. So 11 out of 50 is 22%, 48, 20, 6, 4. Again, notice that they are exactly the same shape. The only thing that's changing is the y-axis. Here are some common distribution shapes. Right here is a uniform distribution. Notice that each of the possible outcomes relatively appear the same amount of time. An example of that might be rolling a dice. So if you roll a die, you'll have 6 possible outcomes, 1, 2, 3, 4, 5, 6. And if you roll the dice 1,000 times, you would relatively expect each of the numbers to appear roughly an even amount of times. Here is that infamous bell-shaped normal distribution where it goes up, peaks in the middle, and then goes back down. Here we have skewed values. So skewed to the right, which means that there are more values on the left-hand side. It's kind of backwards from how your mind would tell you. And then this is going to be skewed to the left. Skewed to the left means that more of the data values lie on the right side of it. Again, we are really interested in normal distributions for this class, which is that generally that bell-shaped curve. Skewness, a distribution of data is skewed if it is not symmetric and extends more to one side than the other. So let's look back quickly. Skewed to the right means that there's more values to the left, and then skewed to the left is more values to the right. And an easy way to remember that is thinking about your feet. So your left foot represents skewed left. So you look at the left foot, more of the toe value is to the right. And then on your right foot, which would be skewed right, more of your toes on your right foot are on the left-hand side of it. So kind of a backwards way than what your mind might tell you. But again, left foot, skewed left, more data values to the right. Right foot, right skewed, more data values to the left. Okay. So Data skewed to the right have a longer right tail, and then data skewed to the left, take a wild guess, oh, has a longer tail to the left. And that's it for this section. Nothing too crazy, just introducing different distribution shapes and histograms.